Welcome to AP Calculus BC video for skill number 237. I can recognize indeterminate forms of limits and use L'Hopital's rule to find the limit. And sticking with our theme of anagrams, the trivia question today is, what is an anagram for stirrup? Alright, way back at the start of our process of learning about calculus, we started first learning about limits. And we used limits to create the formal definition of a derivative. Perhaps you remember the limit as h goes to 0 of f of x plus h minus f of x all over h. That's the formal definition of the derivative. And so we used limits to find derivatives. Now we're going to work in the opposite direction, and we're going to use derivatives to find limits. So when we are using L'Hopital's rule, and I believe there's I think that angle is called a circumflex above the O, if I have my French words right. We're going to use L'Hopital's rule, and we're going to use derivatives to find a limit. Specifically, limits that are in indeterminate form. So L'Hopital's rule only applies if you have a limit that is in an indeterminate form. And what that means is if we do direct substitution and the limit generates a 0 divided by 0 error or a infinity divided by infinity error, then what we have is an indeterminate form. And if we have an indeterminate form, then we can apply L'Hopital's rule. And L'Hopital's rule says if we have the limit as x goes to a of a function divided by a function, and that produces one of our two indeterminate forms, then we can say that the limit as x approaches a of the function divided by the function is equal to the limit as x approaches a of the derivative of the numerator divided by the derivative of the numerator. And it's important to note that if the limit exists or is plus or minus infinity, and a lot of people forget this clause. So if you found this and the limit did not exist, then you could not apply L'Hopital's rule. You would have to find some other approach. So let's see this in action. In the first example, we're taking the limit as x approaches 2 of the natural log of x minus 1 all over x minus 2. And if I substitute 2 in, I would do direct substitution, and I would have ln of 2 minus 1 over 2 minus 2, and that gives me a 0 divided by 0 indeterminate form. And because we have that indeterminate form, we can apply L'Hopital's rule. And so what that means is our original limit can be rewritten with the derivative of the numerator on top and the derivative of the denominator on bottom. And then we apply the limit and see if that works. So in applying this limit, we get 2 minus 1 in the denominator, so we have 1 over 1 in our main numerator and 1 in our main denominator. So 1 divided by 1 is 1. And that limit exists, so L'Hopital's rule is permissible. Sometimes, like in example 2, we might have to apply L'Hopital's rule more than once. For example, we're taking the limit as x approaches infinity, And if we do that for this equation, we get a infinity over infinity indeterminate form. So we apply L'Hopital's rule and we take the derivative of the denominator and we take the derivative of the numerator. And when we take the limit of that, we again get an indeterminate form of infinity over infinity. So because we have that indeterminate form, we're going to take the derivative a second time. So the derivative of 12x minus 5 becomes 12, and the derivative of 4x becomes 4. And now we have a limit where we plug in, and it gives us an answer of 3. And because the limit exists, we can apply L'Hopital's rule. Alright, so in these final two problems we're going to look at kind of an analysis type question. And what I've done is I've presented a problem where a student has done L'Hopital's rule and we're trying to figure out what went wrong. So in the first step they saw that we had a fraction, and so they took the derivative of the numerator and the denominator, and then they took the derivative of the numerator and denominator again, and they went all the way down until we can do basically direct substitution and get an answer of negative sine 2 over 2. So what did they do wrong? And the answer, if we took the limit of the original function, we would find that we have sine 2 over 2 squared. And this is not an indeterminate form. So we cannot use L'Hopital's rule. So then the question is, what went wrong with the second analysis problem? Now in this problem, the student took the limit of the function and they plugged it in and saw that it was infinity divided by infinity. And so what they did is they applied L'Hopital's rule. Applying L'Hopital's rule, they found that the numerator was 1 and the denominator was 1 minus cosine x, and then they input infinity into the problem, and they said, well, this oscillates back and forth, so the limit does not exist because of oscillation. We're oscillating between, what is that, 1/2 and 1 minus 1 over 0. There's some sort of oscillation between those two values. So with that oscillation, they're saying the limit doesn't exist. What did the student do wrong? They forgot the final if clause of the L'Hopital's rule, which says we can only apply L'Hopital's rule if the limit exists. So when we found this limit did not exist, we were not able to use the L'Hopital's rule. So if we wanted to evaluate this limit, we're going to have to find some other method other than L'Hopital's rule. And I'm leaving that as a extension problem for the viewer. If I told you that this limit exists, could you find it algebraically? I'm sure you could find it graphically, but could you find it algebraically? Good challenge.
Around the world, around the
Alright, so at the end of this skill we should definitely be able to tell when L'Hopital's rule applies, and the important catch is that L'Hopital's rule will work if we start with an indeterminate form and we finish with a limit that has a value or is infinity. We will never be able to use L'Hopital's rule to determine that a limit does not exist. So we'll have to approach a different way if L'Hopital's rule heads us in that direction. And the trivia question was, we have the word stirrup, and what is an anagram for the word stirrup? And the answer is erupts, which should not be confused with a very similar word, which is erupts. And a side trivia question is, what is the difference between erupts and erupts? Because they mean different things even though they sound similar. Their ideas are also very closely related. Alright, enjoy your evening. Thanks for watching. Bye-bye.